Hello everyone, in this video we're going to talk about how to solve a three-variable system of linear equations when we get no solution. So what's it going to look like? Well, before we get into the example, let's go through our steps here on how to actually solve a three-variable system. So we're going to start with three equations and three variables. Our goal here is to get that down to two equations with two variables. So that's what we're going to do in step one, try to eliminate one of the three variables. So just to do that, we can use elimination or you could use substitution. Probably most of the time, elimination is going to be easier, and that's going to get rid of either x, y, or z. Once we now have a two equation system with two variables, we're going to eliminate again and try and get down to one variable. So once we have that one variable in step two, we can take that and plug it back into one of the equations we had in step two, and that'll give us the second variable. And so now at step three, we have x and y maybe, or just any two of our three variables, and we can take those two and plug them back into one of the original equations and solve for our final variable, okay? Now, specifically in this video, what we're going to see is this, this sentence right here. When solving, if your variables cancel out and you are left with an equation that is false, such as 0 equals 1, the system has no solution. So let's be on the lookout for that in the example today. And then down here it says when solving, if your variables cancel out and you are left with an equation that is true, such as 0 equals 0, that'd be like an identity, then the system has infinitely many solutions. And we'll have a separate video on what does it look like when we have infinitely many. Okay, so let's get into our example today for no solution. So I have my three equations here, and my goal is to write them as two equations with two variables. So the first thing I see is I have an x, I have a 6x, and I have a 12x. So if I can take my top equation and multiply it by 6, then I can eliminate the x variable. So let's call this 6x plus 6y plus 6z equals 6. And now let's just write this equation as is, and we're going to eliminate here. So 6x plus 9y minus 12z equals 14. And let's go ahead and subtract these so we can eliminate x. So we have 6y minus 9y, so that's going to be negative 3y. 6z minus negative 12z, so that'd be positive 18z. And then 6 minus 14, so we get negative 8. So there's one of our equations that we could use. So far nothing has eliminated, right? Or our variables have not all canceled out. We still have a y and a z. Which means now let's take these bottom two equations, so 6x and 12x, and let's try and eliminate x. So I'm going to take my my middle equation, and I'm going to multiply it by 2. Okay, so let me take off these stars here. And so what I'm going to do is take this equation right here, and we're going to multiply by 2. So this would be 12x plus 18y minus 24z is equal to 28. And now we're going to take that third equation. We already have a 12x, so we're not going to multiply it. So I'm going to draw it down here. 12x plus 18y minus 24z equals negative 11. And now we can go ahead and subtract, but notice what's going to happen. And here's where our no solution is going to come into play. This 12x and 12x, that's going to cancel. 18y minus 18y, that's going to cancel. And negative 24z minus negative 24z, that's going to cancel. So if nothing is left on one side of our equation, we have a 0. And now we have 28 minus negative 11, which would be 28 plus 11. And now ask yourselves, does 0 equal 39? Not the last time I checked, right? So once we get that, we can go ahead and stop our work, and we say there is no solution to this system, okay? And that's how you solve a three-variable system of equations when there is no solution.